Hello friends, welcome to my YouTube channel. Today we are going to discuss output equation of three-phase induction motor. Output equation is expressed in terms of main dimension, that is D and L. D is diameter, L is length of core, and specific magnetic loading and specific electric loading. Now we will derive the output equation for three-phase induction motor. Now output power will be expressed will be expressed in terms of kVA, in terms of kVA. Q is equal to m VPH IPH into 10 to the power minus 3. M is a number of phase, VPH is a voltage per phase, IPH is a current per phase into 10 to the power minus 3. Therefore, Q is equal to 3 VPH IPH into 10 to the power minus 3. Since the machine is three-phase induction motor, therefore we write 3. If it is single phase, we will write VPH IPH. And to convert power into kVA, multiplied with respect to 10 to the power minus 3. Here VPH is approximately equal to EPH. EPH is induced EMF per phase. Induced EMF per phase. Therefore, here instead of EPH, we will write EPH. Q is equal to 3 VPH IPH into 10 to the power minus. Therefore, Q is equal to 3 EPH IPH into 10 to the power minus 3, which is equation number 1. Now we know induced EMF per phase. Induced EMF per phase is EPH is equal to 4.44 F phi TPH kW. Phi is the flux, F is the frequency, TPH is the number of turns per phase, kW is winding factor, which is equation number 2. Now we can write EPH value in equation number 1. Therefore, Q is equal to 3 into 4.44 F phi TPH kW IPH into 10 to the power minus 3. Now we know NS is synchronous speed is equal to 120 F divided by P. F is a frequency, P is a number of poles. We require NS RPM in RPS, that is revolution per second. Therefore, it is denoted by small ns. For this, we have to divide by 60. Since it is revolution per second, therefore it is divided by 60. Now, ns is equal to 120 F by P into 1 by 60. 60 to 2. Therefore, F is equal to P into Ns divided by 2. Write this value of frequency in this equation where F is denoted. Therefore, we will write Q is equal to 3 into 4.44 F. Instead of F, we have to write P into Ns. P into Ns divided by 2 into 5 TPH kW IPH into 10 to the power minus 3. This 2 is divided by 2 into 2.22 becomes. Therefore, Q is equal to 3 into 2.22 P Ns phi TPH kW IPH into 10 to the power minus 3. Now this equation we will rearrange above equation. Therefore, Q is equal to 1.11 kW 5P into 3 into 2 TPH IPH Ns into 10 to the power minus 3. इथे आपण काय केलेलं आहे 3 इंटू 2.22 दॅट इज 6.66. हे 6.66 आपण डिवाइड केलेलं आहे कशामध्ये 1.11 इंटू 3 इंटू 2 3 इंटू 2 6 इंटू 1.11 अगेन 6.66 होतं. फक्त आपण हे पुढे एक रिलेशन लागणार आहे त्यासाठी आपण असं डिवाइड केलेलं आहे. ठीक आहे. Q इज इक्वल टू 1.11 KW to 5P into 6 TPH IPH into NS into 10 to the power minus 3. This is equation number 3. Now current in each conductor that is IZ is equal to IPH, that is current per phase, and Z is total number of stator conductors, which can be found by Z is equal to number of phase into 2 into turns per phase, that is Z is equal to 3 into 2 2ph, therefore Z is equal to 6 tph, therefore which becomes 6 tph IPH is equal to, since instead of 6 tph we can write Z, 6 tph we can write Z, and IZ is equal to IPH, therefore IZ is equal to IPH, therefore instead of 6 tph here, we can write IZ into Z in equation 3. Therefore Q is equal to 1.11 KW 5P into IZ into Z into NS into 10 to the power minus 3. This is equation number 4. Now we have, or we know that specific magnetic loading, that is BAV, is equal to 5P divided by pi dl. Therefore 5P is equal to BAV into pi dl. Therefore 5P is equal to BAV into pi dl, and specific electric loading, that is AC, is equal to IZ into Z divided by pi d. Therefore IZ into Z is equal to AC pi d. Now instead of IZ into Z we can write AC pi d in above equation 4. Instead of 5P we can write BAV into pi dl. Now substitute this value 5P and IZ into Z in equation number 4. ह्या व्हॅल्यू आपण इक्वेशन नंबर 4 मध्ये पुट करणार आहोत. Put these values in equation 4, which becomes Q is equal to 1.11 KW. Instead of 5P we write BAV pi dl IZ AC pi d into NS into 10 to the power minus 3. Now again we will rearrange the above equation. Q is equal to 1.11 pi square BAV AC KW into 10 to the power minus 3 into d square L NS 1.11 KW BAV AC pi into pi square 10 to the power minus 3 in the bracket d into d square L as it is, NS as it is, which becomes Q is equal to 11 BAV AC KW into 10 to the power minus 3 into d square L NS. This 11 is pi square into 1.1, value is 11. Therefore Q is equal to C0 into d square L NS. This Q is equal to C0 into d square L NS. This is output equation of three-phase induction motor, where C0 is output coefficient output coefficient. The value of C0 is 11 BAV AC kW into 10 to the power -3. अशा प्रकारे आपण आउटपुट इक्वेशन ऑफ थ्री फेज इंडक्शन मोटर डिराईव्ह केलेला आहे. जर तुम्हाला व्हिडिओ आवडला असेल तर नक्की लाईक, शेअर आणि सबस्क्राईब करा. थँक्यू.